Ladies and gentlemen, welcome to GSMA and ZTE Online Forum, 5G SA Prime. I'm Baigang from ZTE. In the next 1 hour, we will share the latest 5G SA development and innovation. The first section and also my presentation is driving 5G SA forward, about our vision of 5G evolution to the future network. Firstly, let's see where we are today with 5G. As I started working on 5G since more than 8 years ago, I have witnessed that 5G grew from a concept to demos, then to field trials, finally to full-scale commercial reality. We know 5G SA can import the verticals much more than NSA can, which will bring revolutionary experience to consumers and various new applications to the enterprise. As a pioneer of 5G SA, ZTE has been helping our customers deploy SA and enable vertical applications since years ago. In Thailand, one operator has transformed traditional production lines into smart factories using 5G technologies, which keeps the production continuity during COVID-19 pandemic. In Austria, Austria has developed a smart beehive project, which can make work easier for beekeepers by using 5G live stream to detect environment issues. In Belgium, the 5G Plus smart port has been built in Antwerp, Europe's second largest port, which features the high speed and low latency and supports network slicing for higher reliability. In China, with 5G on the fast track, the operators are working more closely with top industry players to promote digital transformation of energy, manufacturing, and transportation, and other key industries. As we can see, 5G is now changing people's lives and transforming many industries. Another good news is that SA ecosystem is mature now. As a dedicated 5G SA innovator, ZTE has been helping operators build advanced networks in 3 critical aspects: fast launch, superior experience, and vertical capabilities. Regarding first aspect, fast launch, our complete end-to-end SA solution is an enabler. And one great example is that ZTE has made very fast and massive rollout in 2020 for China's 5G Phase 2 projects. In terms of second aspect, superior experience, in addition to our previous innovations such as SSB 1+X and fast fusion assisting Super TDD, we just released the new solutions, Radio Composer, this month, which will be elaborated in a later speech. As for the third aspect, vertical capabilities, the related features include Node Engine and i5G Core, which provide best support to the vertical applications. It is a fact that SA has been valued and deployed by the operators. Looking into the future, when 5G network will create even more values, what technologies can we leverage to achieve that? A new perspective is to look at it through the eyes of the 3 types of stakeholders: the consumers, the operators, and the industries, all of whom have distinctive requirements. What should we do to satisfy all these requirements? Therefore, ZTE put forward this 3E vision and featured technical paths for 5G evolution: extension, enhancement, and efficiency. Supported by chipset algorithm architecture, the 3 fundamental technologies with intrinsic security and intelligence solution, the 3E vision can help 5G evolution move forward towards a more promising future for all of consumer, industry and operators. The first E is the extension of network capabilities to offer much higher capacity, better coverage, and more connections, which should be the solid foundation of an even more capable 5G. Capacity can be enhanced via more advanced ultra-dense network technologies. One of the innovative coverage technologies is reconfigurable intelligent meta service with great effectiveness. In the future, massive connections will stimulate the service with very steady rate. eMusa is such a solution to meet kbps level requirement, while RedCap can satisfy Mbps level requirement. The second E is the network performance enhancement, which will enable a much wide variety of new applications. Wide bandwidth, URLC, and cloud network are recommended here. Multiple time slot for uplink and multiple carrier aggregation solution can increase the bandwidth. Mesh-based NRLAN and user virtualization and cooperation can further meet the ultra-reliable and low latency requirements. ODICT 4+1, as an innovative solution proposed by ZTE, is for the convergence of operation, data, and RCT, targeting precise, intelligent, simplified, and reliable network. Based on the first two E, the third E focuses on the resource utilization efficiency and address the challenges to the operators for building quality 5G network in a more sustainable way. Energy, spectrum, and operation are the three main considerations. Our experience and know-how in chipset and AR will help improve the efficiency to the next level. More spectrum utilization and new enhancement can be introduced to improve spectral efficiency. ZTE's ARVO, AR Insight Value Operation Solution, improves efficiency in the dimensions, precise planning and deployment, smart O&M and optimization, and value-oriented operation. As a summary, this framework shows all key messages with three fundamental technologies: chipset, algorithm, architecture, and two intrinsic solutions: security and intelligence. I believe that 3E vision can help all consumers, industry, and operators move towards a value-centric 5G evolution. Thank you for your time and have a nice day.
Hi everybody, my name is Peter Jarek. I'm the head of GSMA Intelligence, and I'm excited to be here today to talk a bit about standalone 5G and what we're seeing here at GSMA Intelligence, or as I like to call it, standalone 5G. How are we doing and why exactly do we care? So for those of you who aren't familiar with GSMA Intelligence, my team's the research and consulting arm of the GSMA. That means it's our job to deliver research, data, insights to help the market execute on the opportunities in front of it. That means market forecasts, where are we going with IoT, with 5G, with previous generations of technologies, helping our customers with product launches, service launches, corporate strategies across the mobile ecosystem. If you're a customer, thank you very much. If you're not, would like to learn more, please reach out. Always glad to talk to you about what we're up to. But with that out of the way, let me get to the content that you want to hear about, which is talking about standalone 5G. I want to start with a very simple context setting recognition. We are now firmly in the 5G era. Now that may seem obvious for a lot of folks, but for many of us, we lived through years of talking about when 5G arrives, we're going to do this. 5G will enable the following things. How do we get to 5G? And it's important to recognize we are there now. So what you'll see on the screen are some of our research from our latest 5G quarterly update. And I think most of this will be familiar to you, but it's important to recognize we're at a place where 5G is very much now a commercial reality. Right? To the end of Q1, what did we see, right? We saw 157 operators, 62 markets with commercial launches, 230 plus million connections, right? Going out to the end of the year, more than 550 million connections. Going out to 2025, 1.8 billion. We're no longer talking about what happens when we get to 5G. Now, it's also important to recognize, as you see on this next slide, that the big motivation for many operators when they think about 5G is the enterprise market. Right? When you talk to CEOs, vast majority of them, 83%, say they think it's the enterprise that will deliver them a revenue uplift around 5G. And it's not too surprising. Why? Because if you look at their revenues, and you'll see here some research that we did not too long ago, you see that for most operators, their revenues are coming from the consumer side of things. At the top level, we're talking about maybe 40% of revenues from the enterprise. That goes down to less than 15 for some. So there's a recognition here that enterprise, that's a huge upside for them if they can manage to tap it. And 5G as a technology provides a huge opportunity. But this then brings up a question that I think we all need to recognize. Can today's 5G, non-standalone 5G networks and services, can they really support operator enterprise goals? Can it give them what they need, the differentiated capabilities that allows them to tackle the enterprise service opportunities? Now, spoiler alert, the answer is sort of. And I say sort of because in many cases, operators, they're successfully targeting new enterprise use cases with their existing non-standalone service launches. Cool. But for many, it will not deliver the capabilities they need. Standalone is what they're looking for. So on this next slide, what do we see, right? A very important recognition of what standalone 5G brings. So for many operators, when they think about standalone, they think of it as their target 5G architecture. And why is that? It's the target 5G architecture because it brings them the capabilities they need to go after the enterprise. And what are those capabilities, right? Lower latency services for those use cases in the enterprise that require that type of interactivity. Consistent 5G coverage. Because in many cases, we can't talk about, well, I've got the latency and I've got the speed that I need here, but maybe not somewhere else. You need that consistency to deliver the reliability, to deliver those expectations that enterprises need. And of course, enhanced slicing. We've been talking about slicing for years and how 5G will enable it. But really, much of what you get with slicing only comes with standalone. So it's that combination of latency, consistent 5G coverage, enhanced slicing capabilities that are really what operators are thinking about when they say, hey, I'm going to go after the enterprise. These are the capabilities that they actually need. Now, of course, there's a foundational layer of capabilities that standalone brings. We're talking about simplified device architectures, simplified RAN architectures. We're talking about cloud native core. That's great. But it's those capabilities in terms of latency, in terms of coverage, in terms of slicing that operators are looking at when they see 5G as a way to help them in the enterprise. So now that's the theory, but when you talk to operators, what do you find out? Well, as you see on this next slide, what we find out when we talk to operators is that standalone is at the top of the priority list, right? So position is this. Hey, Mr. Operator, what do you think are the important technologies to help you with enterprise success? You see, there's a whole lot of things that they're looking at. Standalone 5G comes on top. Now, I show here on this slide, standalone 5G compared to edge. Not to say that edge networking isn't important. Edge networking, very important to operators. Most operator enterprise launches include some level of edge networking. But compared to edge networking, you see they see a 5G standalone as critical. And that's important to recognize. Now you can ask, okay, well then where are we with this? Where are we really? How are we doing with standalone 5G? Well, I want to start off with a question of networks and use cases. On the network side of things, we find that if you look across the top network infrastructure vendors, right, the top 5 that I show here, you see they all have a standalone core offer. They all have a standalone RAN offer. We're not at a place where if you're an operator, you're looking to deploy standalone 5G, you're going to have a difficult time finding a vendor to support you. They all are ready to commercially support operators with that. And I think it's fairly clear that from an operator perspective, the use cases are well understood. I talked about the core value proposition, but we see how those can be translated, right? Things like if we're talking about manufacturing, we're talking about low latency machine operations. If we're talking about healthcare, we're talking about low latency machine control. Now, I know remote surgery has been held up for a while, and maybe most of us wouldn't be comfortable with that. But the idea that the low latency provided by standalone 5G can help with machine control. We're talking about things like transport and logistics. We're looking at wide area slicing because you may want to deliver a slice to deliver specific SLAs and capabilities. You're not going to deliver a private network on a wide area, but with slicing over a wide area, I can deliver those capabilities that those particular customers need. And then, of course, on the IoT space in general, the idea of delivering super dense IoT connectivity, which comes with standalone. Now, that could be consumer or it could be enterprise, but it's important to recognize that that will only happen when we get to standalone. Now, of course, the question is, that's great. Networks are there. We understand the use cases, but then where are we in terms of actually getting this rolled out? So on this last slide, I want to look at the operator perspective and the device perspective. From an operator perspective, if we look at the number of operators who have deployed 5G, what do we see? Well, we see 35% are actively investing or committed to starting to deploy standalone. Right? That's some level of commercial deployment, commercial trial, stated deployment timeframe. Now, I think you know some of the big names, the operators in China, see T-Mobile in the US, STC. There are a number of high-profile ones, and I think day by day we see those in the media every single day, new launches. We're definitely seeing 2021, a lot more momentum for it. That's great. But of course, there will be the question of how do we get this to be mainstream? Particularly, not just enterprise, but consumer side of things, what does that mean for devices? Well, if we look at the device side of things, I think the important number here is 34%. Now, that's the number if we look at 2020, and we look at the GCF and the device certifications, we saw 34% of the 5G devices certified in 2020, 34% supported standalone. Now, I show 4 of them here, not because these are the 4 most important, but because these are 4 very popular ones, right? Flagships from Apple, the iPhone, flagships from ZTE, flagships from Samsung, flagships from OnePlus. And the important part here is we're at a place now where the flagship device launches will include standalone. And more, we will see those device launches as a general rule, including standalone, which is important because it says we have now arrived, not just in the 5G era, but we're very close to being in the standalone 5G era, where it's just the default. So with that, I'd like to say thank you all very much. I appreciate you all for listening. Look forward to more of the insights from the rest of the day. And as always, please stay safe.
Hello, everyone. Today, I'm glad to share with you ZTE Radio Composer, which is the industry-first orchestration radio network solution. Each core has 2 sides. For one thing, each generation during the mobile network evolution provides better and new services. For another, it becomes increasingly complex, with the multiband and multi-res coexistence, as well as more differentiated services carried over the network, such as V2X, autopilot, and cloud gaming. The requirements for network capabilities increases. In addition, 5G terminals varies by bands, bandwidth, and carrier aggregation combos. In short, the 5G network is facing unprecedented challenges. When you are cheering for your favorite team, you will instantly lose your passion when the video gets stuck. When you are in the middle of an online battle for your video game, the network delay will directly kill you. That's what happens to 2C users in certain scenarios. Since our current strategy is based on network KPIs instead of end-user experience perception, the current 5G network for 2C cannot always guarantee end-users' experience. For 2B services, the current approach has overassigned the network resources to ensure the strict SLA requirements. Facing the complicated and changeable application scenarios in the 5G era, we need to change the network strategy from network-centered to user-centered. Therefore, ZTE launches the first intelligent orchestration radio network solution, the Radio Composer. ZTE Radio Composer, based on our smart orchestration engine, incorporates complex telecommunication variables to build precise end-user perception capability in order to obtain the optimal performance. To be specific, I would like to use a formula to illustrate it. S, the service, stands for the services type such as 8K HD video or online gaming, and service pattern like data sending cycle and service priority. L, the location, is the user location information based on radio frequency fingerprint. D, the device, represents the differentiated capabilities of terminals such as bandwidth and carrier aggregation combinations. Delta stands for the extra information outside the telecommunication field. N is the network service capability that varies from 1 to X, indicating different capability combo. Basically, we interpret radio network as a function that has its input and output. Through the redefining and expansion of the input, we can match the service requirement and the network resources precisely. We guarantee that all users experience the P-optimal shall surpass the appropriate baseline anywhere, anytime. We achieve it through finding the most suitable combo between 1 and X. That's the mechanism behind our user orchestration that aims at optimizing individual experience. For another orchestration, the network orchestration, we adjust the capability combo themselves in a cell cluster so that the collective demand within this area can be satisfied. Overall, user orchestration and network orchestration together make ZTE Radio Composer. User orchestration is a real-time traffic steering for optimal user experience. Network orchestration provides a flexible shift for the configuration. Generally speaking, the radio composer can be compared with an intelligent urban traffic system that includes multiple roadways such as the bus lane, the fast traffic lane, and the truck lane. User orchestration serves the function of guiding individual vehicles into the right lane, while the network orchestration adjusts the number of different lanes provided and the direction of lanes in a certain time period according to the overall traffic situation. So, where does the computing power of this smart orchestration engine come from? It comes from BBU intrinsic, node engine for 2B scenario, and inter-BBU collaborative, which end up together construct a 3-layered computing power. To fully understand the functionality and the benefits, we need to further explore on user orchestration. The main idea is to divide existing cell into logical grids, with each grid representing a specific wireless condition. This multidimensional structuring process starts with first establishing a logical grid knowledge library, including multiband signal strength, spectrum efficiency, and some others, so that we can accurately predict the user experience of different grids. Second, analyzing the service types, service characteristics, service priority to help precisely identify requirements of users. Third, combining the grid-specific user experience prediction with the accurate service requirement while taking the terminal capability into consideration so that to guide users to the right grids. Using user orchestration, the user can be precisely guided to the most appropriate combo. Next, network orchestration also plays an important role in ZTE Radio Composer. Network orchestration forms network grids by clusters of base stations. In network grid, differentiated network capability sets are provided through the combination of different configurations, such as multi-mode configurations, bandwidth using by each mode, and frame structure. The traffic demand within such a clustered grid can be measured through recording the proportion of users of different routes and the ratio of uplink and downlink in each time periods. Through matching the prediction of traffic demands with capability sets of grids, network configurations can be precisely deployed to ensure that the total service demands within the grid can be perfectly satisfied. For example, many operators currently suffers from the performance of DESs. With the usage of network orchestration, network configuration can be altered from LT-NR DSs to NR only, improving NR users' experience greatly. Our testing results with China Unicom last month has shown that the average 5G user throughput can be increased by 20% to 130%. Facing the future, Radio Composer will continue to grow and evolve along with increasing demand, and will build a real intelligent RAN. Radio Composer can be driven by different intentions. For example, the intention of energy saving. The intention can be broadened by introducing the information outside the communication field. By means of the techniques of digital twin, the digital world can support a more accurate and efficient radio composer. We believe that Radio Composer will become a symbol of 5G advanced and beyond in the near future. Thank you.
Good day, ladies and gentlemen. My name is Jason Tu from ZTE Corporation. I'm now acting as a principal scientist of ZTE NFV SDN solution. Today, my topic is about all-in-one 5G private network. From the picture, we can see from the right, coming from the OMIDIA, that's the most important reason for Vertical to choosing a private 5G partner is about security. The second reason is about economy. So you can see there are a lot of motivation for the vertical industry to choosing a private network dedicated for their service. And from the picture on the left, we can see the biggest part of the vertical industry is coming from the manufacturing. And the second part is for the logistics and the transportation. We can see from that, all these vertical industries that have introduced private network are super large enterprise. Thus, small and medium enterprise do not need private network? The answer is not. They do need private network for their dedicated service, but they have some issues. The first block issue is about frequency. You know, in most of the country, it's difficult to purchase a frequency, not only for expensive, but also for some reasons. The second reason is that because LTE or even 5G are become more and more complicated. For the enterprise, it's not for the IT or CT part, it's difficult for them to deploy, maintain, and update all the network for all the times. So we can see from that, for the vertical industry side, they do have huge requirements to introduce a dedicated private network for themselves, but they have some issues. From other point of view, from the operator point of view, that's a great opportunity for a big business. There are 4 typical modes for operator to provide private network for the vertical industry. The mode in the first is just like isolated network, which are independent RAM, independent transmission, independent core network. So of course the network is deployed, maintained, and operated by operator. But enterprise could enjoy almost a physical independent private network for themselves, but they do not need focus on the frequency, maintain, and update. The second mode is about shared mode, because only for the most expensive part, the RAN side, are shared by the public network, but for the core network and transmission could be independent. So this is one of the hybrid one. Also the cost is in the middle. And the third one is also the hybrid one, is that it means the core network, control plane is centralized, shared by the public network, RAN is shared, but the UPF, the UPF, user plane of the core network, is dedicated, distributed to the enterprise. That is, all the data in the park, in the traffic, could be local looped, will not go outside, it's more security. And the last one is completely the software-based one. By network slicing technology, all the elements, for the RAN, transmission, core network, are completely shared by public network. But for the logical side, it's an independent logical private network. And of course, the last one is the most economical one. So for operator, they can providing a lot of way for different type of the vertical industry. ZTE full scenario private 5G network solution. ZTE can have a lot of solution to help operator to set up private 5G network for the vertical industry. From the first one, we can see we have a standard cabin for the 5GC, I5GC, I stand for the industry, and we have a BBU inside, OLT inside for the fiber access, and of course we have what we call the cloud cabin, which we introduce mobile edge computing capability on the cabin. And of course, we can introduce some third-party cloud platform such as Amazon Outpost cabin on the left. So in this case, it's a big solution for those super large enterprise. The capability is about 50 Gbps. In the middle, we have a middle size, half size of rack, and also industry 5GC are inside, BBU are inside, and we have a slide computing capabilities for the vertical applications. And of course, for the smallest one, which is just one standard server, and everything inside, it could be support almost all the function about private 5G, and the capability is about 5 Gbps as well. From ZTE, we can provide a lot of independent full scenario solution for the operator and helps operator to providing a private network as a service to the vertical industry. So this is a business model for private 5G. With the help of like a vendor, that we have a lot of scenario for software-based, hybrid mode, and a completely hardware-based private network. So for different type of the vertical industry, so they have a different business model. For example, for operator can set up a priority models for those small and medium vertical industry. And I mean, by introduce pure software network slicing, so those vertical industry can buy a private network, pure software. I mean, all the resources are shared by public network, which is the most economy one for this small and medium enterprise. Of course, the economy is the best. And the second one is exclusive. Some of the elements of the network are shared by the public, for example, the RAN. So this is for some dedicated hardware. For example, the UPF will be distributed to the park, to the factory, and all the data will not go outside the park. So this is much more security compared to the pure software one. And the last one is the horrible business mode. So in this way, operator can selling a completely hardware independent private network to the vertical industry. So you can see for the mine, for the harbor, so this is high SLA requirements, the scenario, the vertical industry can enjoy this one. So you can see from this business model, now operator are not selling terminal. They are selling customized private network as a service to the vertical industry. And the vertical industry were focusing on their own business. They do not need to worry about the frequency. They do not need to think about how to deploy, how to maintain, what time to update the whole network. Just enjoy the service. I think this is a win-win situation for both operator and a vertical industry. Okay, let's come to a case which ZTE helped the operator deploy this kind of private network for the Antwerp harbor. So we introduced standalone based 5G network in the harbor. So you can see we deploy a lot of RAN, transmission, and core also distribute on the park. So there are 5 enterprises buying private network from the operator. And these 5 enterprises each have a logically independent private network for them own application. So they do not need to maintain the network, just buy the network service from the operator. And you can see from because we distribute UPF to the park, and all the data will not go outside the park. and all the data will loop inside the park, so it's much more security. This is a wonderful, excellent case that you can see. Vertical industry enjoy their private network service, and operator are using the public network, but not only providing public communication service, but also they are providing private network service to this dedicated enterprise. Okay, that's all for my presentation. Thank you for your time and attention.
Welcome to my presentation on the 5G evolution of the Hutchison 3 Austrian network. My name is Mario Bayer. I'm responsible for network strategy. First, I want to show you some figures. On the left-hand side, you can see the monthly data volume in the 3 Austrian network. You can see a split into 3G and 4G volume. Currently, the majority of data is on 4G. Only about 2% we still have on 3G. On 5G, data volumes are growing. Currently, the volume is less than 1%. We have about 3.8 million customers in our network. The data volume per customer is quite high. So we have an average data volume of 30.5 gigabyte per month. This very high volume is related to the usage of internet at home, which is fixed wireless access substitution, and provides customers with very high data rates in their homes. On a worldwide ranking, we are on number 3 with this data volume. Next, I would like to go to the radio deployment in our network. We have about 6,000 sites in our network. On all of these sites, we have deployed 1800 MHz and 2100 MHz. With these spectrum parts, we provide 2G, 3G, and 4G coverage. For capacity, we additionally have 2.6 GHz in DDD and FDD mode. In DDD, we use massive MIMO 64T, 64R. For coverage, we additionally use the 900 MHz band. Here we split the spectrum in a part for 2G and a part for 4G. For 5G, we started our deployment with NSA. Currently, we use the C-band with 64T, 64R massive MIMO equipment. All the radio and the core network equipment in our network are from ZTE. Our 5G journey. The first major step into 5G was happening in December 2018. We deployed a trial on our campus area and reached speeds up to 2.3 gigabits per second. In March 2019, we had a showcase to the mayor of Vienna. The use case was a video deployment, a 360-degree camera. In April 2019, we acquired C-band spectrum. Actually, we acquired 100 MHz, which is optimum for initial 5G deployment. In September 2019, we launched our 5G network to customers. At the beginning, we focused on the area of Linz, which is a medium city in Austria, and we deployed full 5G coverage with about 50 radio sites in this area. Additionally, we built sites in the major cities of Austria. In February 2020, we provided full 5G coverage in the first office tower in Vienna. This is the peak tower with 31 floors, and we implemented 85 Q cells, these are the small cells of ZTE in this tower. With this deployment, we have full 3G, 4G and 5G coverage in this building. In October 2020, we acquired additional spectrum in the frequency bands 700, 1500 and 2100 MHz. This spectrum is the basis for our 5G standalone evolution. In January 2021, we started our research in the Industry 4.0 area. We provided campus coverage to the pilot fabric, which is a 4.0, Industry 4.0 research area, and we started a cooperation with the Technical University of Vienna. In May 2021, we launched our 5G standalone field pilot. We deployed a 5G core network and we implemented standalone dual mode in the radio area. And a few weeks ago, we started the testing with UEs from several vendors. The target is to build a future-proof network. This includes the modernization of the existing network, a network cloudification. This cloudification is most important for the core network to have the possibility to have the new architecture of the 5G core network. Therefore, we deployed already 2 years ago a cloud telco platform from ZTE. And finally, it's very important to improve O&M efficiency in the network. The radio solution we use includes massive MIMO, currently 64T, 64R for the C-band and for the 2.6 GHz band. And it includes dual band radios in 1800 and 2100 MHz and in 700 MHz and 900 MHz. For the rollout, we focus the C-band to urban areas, and in the rural areas, we will mainly use 700 and 1500 MHz for the coverage. We decided to use ZTE equipment also for this evolution for the whole network, including radio and core network. This concludes my presentation. Thank you for your attention.
尊敬的各位嘉宾朋友们，大家好！很高兴能在这里与大家共同探讨共建共享和 5G SA 网络的发展创新这个话题。当前 5G 产业正在全球蓬勃发展，并逐渐从非独立组网向独立组网演进。唯有锐意探索、不断创新，才能化解网络部署当中的诸多挑战，激发 SA 的价值。全球 5G 发展已经进入快车道，截止到2021年4月份，全球已经超过435家运营商开展了 5G 建设，部署了162张商用网络，建成了110多万座 5G 基站。5G 终端发货量已经达到了5亿多部， 5G 用户数也达到了4亿多。中国的3大运营商全部实现了 5G SA 的规模商用。5G 产业在网络规模、技术能力、应用创新等方面均呈现出良好的发展态势。从2019年9月9日，中国电信和中国联通签订了共建共享协议以来，截至今年4月份，已经累计开通了40万 5G 基站，取得了1张物理网络、2张逻辑网络的卓越成果，在多个方面进行了创新和突破。首先，我们经过大量的技术验证与综合考虑，选择了接入网共享技术，避免了对核心网的改造，创新实现了4G 单锚点和双锚点共存部署，满足了快速部署网络的需求，实现了 NSA 到 SA 的平滑演进，确保了 SA 网络站得上、住得稳。其次，我们通过技术合作攻克了设备、节能、资源调配等诸多的技术难点，实现了高效、智能、低碳的网络运营。最后，我们充分发挥电信联通的频谱共享优势，打造了一张优质的 5G 网络，使得重点城市 5G 下行的平均吞吐速率可以达到1000兆，打造了极致的用户体验。下面我着重分享2个方面的问题。 在 5G 网络的运营过程中，我们和中兴通讯深度合作，突破了共建共享的诸多挑战，取得了一系列的技术创新。第一点，要共建共享，设备带宽需求成倍增加，室外要支持200兆，室内要支持300兆带宽，同时既要保证公离谱密度，还要提升系统效率，并降低设备的体积。经过共同努力，我们采用先进的7纳米制程芯片，把功放效率提升了近50%，实现了大带宽设备的规模商用。第二，我们开展了 2.1G 4.5G 的动态频谱共享的 DSS 验证，让网络协同更高效。此外，开展了 3.5G 与 2.1G 高低频的深度融合验证，充分发挥不同频段的优势，提升了覆盖和容量。第三，我们提出了 ICL 的方案，实现了1个物理小区、2个逻辑小区，双方可参数配置解耦，网络架构可自定义。针对资源的划分和分配，我们提出了以 PRB 为力度的硬切片方案，可实现频谱的灵活分配、按需隔离、高效共享。节能降耗是网络运营商所面临的一个重大挑战。通过引入智能节能平台，在传统的基础节能之上，通过化物预测及效果评估来智能优化节能参数，并将用户导航到最佳的制式和平层上，从而达到最优的节能效果。该方案在成都电信的测试当中达到了34%的单站节能效果。我们还引入了广播波束的优化创新方案，在保证水平覆盖的基础上，可将垂直覆盖效率提升30%以上，下行速率提升25%以上，保证了高层楼宇等复杂场景的覆盖效率。我们一直致力于推动 2.1G 频段的40兆带宽的重耕，并通过高低频协同来提升网络品质。我们通过和中兴通讯的合作，验证了多载波协同技术，将覆盖提升18%以上，让 SA 网络更加独立。为拓展 To B 的应用蓝海，激发 SA 网络的价值，我们在 5G SA 架构的基础上，将真结构增强、载波聚合、边缘算力以及无线硬切片等创新技术封装为多项网络基础服务能力，并将其应用于千行百业。目前，我们 5G 行业应用已经遍地开花，比如南京滨江的 5G 智慧工厂、深圳盐田港的智慧港口以及扬州智慧社区等等，并通过绽放杯大赛持续将 5G 之花浇灌为新的果实，为更多的行业应用高效赋能。下一阶段，我们将继续深化合作，共推技术创新，共促产业发展，共创美好未来。谢谢大家。
Good morning to everyone. My name is Fulvio Margherita. I'm responsible for RAN, microwave and device engineering in Wintry company in Italy. We had a tender for new vendors and we assigned the RAN deployment to ZTE and Ericsson. So the overall result was a large network with large coverage and large capacity. The target was not only to reach a large capacity network and a high performance network, but also to have a network ready for the future. So what we did is to build a network based on new architecture. On 2017, LTE was a mature technology. Our request was to have a BBU and RU architecture so that the RU could be deployed near the antenna, having a high efficiency and a higher coverage. And also to have a single RAN network where all technologies from 2G to NB-IoT going through the 4G were managed by just one single baseband unit. TDD rollout is mainly targeted to hotspot areas, so not based on coverage contiguity, but trying to reach first the area where traffic is concentrated. The result of this, of course, is that the coverage of 5G TDD is not contiguous. So the idea was to have uniform and contiguous 5G experience for our customers, exploiting the possibility to roll out nationwide also a 5G FDD technology, which was possible through our new equipment, which was already able and hardware ready to manage the 5G FDD technology. That was a specific advantage we had on our competitors, which had still a not modernized network. With this project, we were able not only to provide this uniform 5G experience, but also to get some advantages from 5G TDD. For sure, we can increase the TDD coverage as soon as the FDD and TDD carrier aggregation is available, and today it is already available. And the third advantage was to have the possibility to reduce latency, exploiting the joint management of FDD and TDD transmission, of course, based on the availability of an SA architecture core network. But our technology is also able to provide us additional advantages. For example, in these years, some technologies like the 3G are, let me say, no more used by our customers. There are a few users on that technology. Still, we cannot get rid of them since almost all of those users have changed their smartphones. So the idea is that we have the possibility to have a dynamic and smart allocation of the 3G spectrum to 4G based on the actual capacity used by 3G. And that can be done dynamically during the day and on a cell base. So we will be able to have the most efficient use of 3G spectrum, reallocating it on the 4G service. But that is, let me say, the business as usual. The new challenges for the futures refers to how we are able to manage the increasing complexity in the RAN management. All of us knows the complexity ranging from the explosion of number of possible combinations of different spectrum of different carriers, and also the complexity due to the fact that not all UEs with all the capabilities to manage all those combos. So there is a large fragmentation in the device models and in the kind of combination available on the network side. So a possibility to manage comes no more from normal configuration, but it must be achieved through some smart management based on the network behavior. I do not know if it can be achieved by artificial intelligence, but for sure network must become much more smart than today. So for sure, this is one of the advantages that artificial intelligence can bring to our normal operation. And there is also another point where artificial intelligence can increase our efficiency, and it is on the management side. For example, the largest impact on operation of the network is due to the field activities. Well, those activities, of course, cannot be deleted by artificial intelligence, but they can be made more efficient through the fact that today we are compelled to go even twice or 3 times on the same site because we have not clear the root cause of the problem, and that cause creates large inefficiencies. With artificial intelligence, I expect that the equipment is able to tell to the operating center what is the problem and what have to be done by the field which reaches the site. In that way, just once the field shall go to the site to make the restoration of the service. Another important target, both environmental and economic, is the capability of the equipment to save energy. I have not to explain how much the cost of energy is a significant part of the operator OPEX. The technology we have in the field is able to provide us several tools to have this energy saving, both through very fast symbol level power switch off and on a much slower process based on the average traffic carried by the network. So for sure we will use these capabilities for the next years in our network. And of course the possibility to save energy will still become much more important with the 5G deployment. It was a pleasure to speak and to tell about our story here at the MWC. I'm really happy that this year again we have the possibility to attend physically that important conference. And I'm really proud about what we did as operators all over the world to guarantee to all peoples the possibility to remain connected and to shorten the distance between all of us. So thanks again.